Welcome to Chronico. Today I'm going to be showing you how to easily create your own machine learning algorithm with Python. Today we're going to be using two special libraries to make things easy for us, Pandas for data manipulation and Scikit-Learn for machine learning. Feel free to follow along with the code on GitHub. There will be a link for that in the description. You're welcome to use whatever environment you would like for this. I like to use Windows Subsystem Linux, but you could also use the Python idle editor or whatever. And of course you're going to want to start off by installing Pandas and sklearn with whatever package installer you use. For most of you that'll just look like pip install sklearn and pip install pandas. And it's as easy as that, and then we can get started. At the most basic level, a machine learning model takes in some training data to analyze and builds a mathematical understanding of the data. Then, the model can be fed some data to make a prediction about. Today we're going to create a machine learning model whose input data is a food item. More specifically, the input data are the amounts of protein, fat, and carbs in some arbitrary food. Our trained model will be able to take this data and make an accurate prediction about the number of calories in the given food. So, how will we accomplish this? Using a very basic machine learning technique called linear regression. This technique assumes that our prediction function will take a linear form. So, what exactly is a linear form? Since you're watching this video, you've likely encountered the equation for a line at some point, where x is the input variable, m is the slope of the line, and b is where the line intercepts the y-axis. We can simply tweak this equation a bit to create a line with multiple x input variables, like protein, fat, and carbs, with a different value of m for each. So if our goal is to predict some value of y, given some x1, x2, and x3, then all our model must know are some decent values for m1, m2, m3, and the intercept. We estimate these values by training our model on a set of data with real values for the x's and y's. The training process will find the values for m and b that best fit the entire dataset. To train our model, we're going to need a lot of data, so we can go over to kaggle.com and pick up a data set with the nutritional content of food. We've got all these columns with a short description of the food, the amount of water in grams of the food, calories of the food, protein of the food, fat total, ash content, carbohydrate in grams, and the fiber. And we've got rows and rows and rows and rows and rows and rows and rows of this. So we're going to go ahead and download that. I've already got it downloaded right here. So yeah, we can replace that. Show in folder, and then we're going to need to extract the data set out of here. Alright. And then it's going to give us this CSV file. We can take a look at it in Excel if we want. Lots and lots of columns here. But don't worry, we're only going to need a few of the columns. Particularly the calories right here. We're going to use lipid total, the fat, protein, and carbohydrates. So we only need those 4 columns. Back to WSL, I'm going to copy that file over from my C drive, and I'm just going to put it into this folder and call it abbrev.csv. Now I'm going to open my Python document, call it linreg.py, and we're going to start by importing a few classes and functions. So from the pandas library, we're going to import read CSV. This is going to allow us to read the data from our CSV file into an object called a data frame. And then from sklearn, the Scikit-Learn library, in the linear model module, we're going to import the linear regression class. And that's going to be the object that contains our model. We're also going to want to import a function that splits our data into training and test data so that we can see how well our algorithm did. So that's going to be in the sklearn.model selection module, and it's called train test split. Alright, and to start we're going to want to read in all of our data. So we'll get a little object called food data, and we're going to read CSV from that file abbrev.csv. Now, this will work if the file's in the same folder as your Python file. Otherwise, you're going to want to specify what directory it's in or wherever you put it. Then, since we only need a few of the columns, not everything, we're going to specify which columns that the data should be extracted from. And to do that, we're going to have to take a look at our abbrev.csv file and pick out which columns we want. So the first column is index, that's 0 column. And then this number, the short description, is index 2. Water is going to be the index number 3 column. And calories, which we want, is column 4. So we'll take 4, and then we need protein. So we need 4, 5. We need lipids, so we need 4, 5, and 6. And then carbohydrates over here, we're going to take that too. So we'll do 4, 5, 6, and 8. So we'll head back over to our Python file. And we will use the columns 4, 5, 6, and 8. Now we can just take a look at this food data by printing it out, and then we'll just run this code and see what it looks like. It's going to print out this data frame where we've got the calories right over here. We got protein, got lipid totals, and we've got carbohydrates. So for each food item that was in that data set, we can see the number of calories for the item. We can see how many grams of protein, how many grams of fat, and how many grams of carbs. And we want our algorithm to be able to take these three numbers, the protein, the fat, and the carbs, and then return a number of calories. So we're going to call proteins, lipids, and carbohydrates our X data, and our calories are going to be our Y data, or our target variable, which we want to predict. When we read this data over from the CSV file, Pandas is automatically going to replace any missing values with not a number, or nan. So to clean up our data, we're going to just want to remove all the rows that have nan in them. We can just use the handy data frame method drop na, and that's just going to remove all of the rows and return a fresh data frame without any rows with missing values. Now that we've cleaned up all the rows, we're going to want to separate our target variables from the rest of our data. So our target variables, of course, are the calories. And that's going to be the first column of our data frame. So we can create an object called calories, and we're going to assign it to just the first column of our data frame, where our calorie data is kept. So to do this, we can use the index locator method of the data frame. The first argument of this is what rows you want. So you could say you want the first row to the 22nd row, and it'll give you all those rows out of the data frame. But we're going to use all the rows because we want all the rows of data of calories. For the columns, which is the second argument, we're just going to use the 0th column of our data frame, which is our calories column. Now if we print out calories, oh, what did I do? Food frame. Oh, food data. Yeah. Okay, and now you'll see that we've printed out the column containing all of the calorie data. And this itself is another data frame. Now to extract the rest of the data, the protein, fat, and carbs data, we're going to use the iloc method again, take all of the rows, and we're going to take the first through the last column. So that's how you notate that. And then we can print out this data frame as well. Take a look at it. And you'll see the 3 columns of data that we need. Now that we've separated our target variables from our input variables, we're going to want to split our data into training and test data. So to do this, we can use the function that we imported, train test split. And this is going to take your X data first, or your input variables, which is going to be our protein, fat, and carbs. And then next is your target data, calories. And then we're going to set the test size to 0.01. So 1% of our data is going to be test data. Now typically you want to use at least 15 or 20% of your data as test data. But since we're not going to go back and analyze how well our algorithm did, we can just have a very small test size so I can show you. Now this function is going to return 4 variables. First one is going to be the X training data, X testing data, the Y training data, and the Y testing data. Now we're going to want to create our model. So to create our model, we're going to make a linear regression object. And it's going to handle all the math for us. We can assign that to a variable. I'll call it Linda. She'll be our model for today. And then we're going to fit Linda with the data that we're using to train it, the X train and the Y training data. So now that we have a fitted model, we can use it to predict our X testing data. Using the .predict method, we'll return a list of predicted values. So we can call these our predictions. And those predictions should, in theory, if we had a perfect algorithm, be equal to the values that are stored in our Y test variable. So we're predicting the calories associated with all the values in X test. And if we want to check what these predictions look like, we can just print that out and run the code. So this is the list of predicted values. We could also print the Y test. And Y test contains all the actual values associated with the rows in X test. So we're going to print our predicted values, and then we're going to print the actual values. As you can see here, the second part printed out differently. That's because the Y test is still associated with a data frame object, which has its own print method. But the predictions just come out as a list. We can see the first value that we predicted was 73 calories, and the true value was 71 calories. Second value that we predicted was 18 calories, and the true value was 15. So we're not far off, but we can go back and we can test some of our own values if we want. We can start by taking some input from the user, take protein in grams, fat in grams, and we'll take the data for carbs in grams. So we can assign those to some variables, and then we can use that data to create a prediction. So we'll use our model, .predict, and this predict method takes in a 2x2 array. So we're just going to put our list inside a list, like that, and then it's going to give us our prediction. So then we can return the amount of calories that we predicted. If we leave our input collection like this, we're going to get an error because our algorithm expects numerical values instead of strings. So we convert all the strings to floats and we shouldn't have that issue. At this point the model's already trained and we've got a way of creating new predictions. So now we can go ahead and execute our program. I'm going to go grab some food so that I can test it. Alright, I've got some crackers here with some nutrition facts. So let's go ahead and run our program. We got 1 gram of protein. We got 3.5 grams of fat. And 11 grams total carbs. And as expected, our algorithm returns the number of calories. It predicts 80.85. And would you look at that? 80 calories right there. That's pretty spot on. So our algorithm works, but as you can see right here, we get an error from sklearn. X does not have valid feature names, but it was fitted with feature names. So this basically just means that our columns are labeled in our data that we fed to the algorithm, and then we predicted without that column header. So to avoid this, we can just use the .values attribute of our data frame when we split our data, and this will just get rid of all the headers. So then we run it again, and we don't get that error. So once our model is trained, its prediction function is extremely simple. We can go ahead and look directly at the coefficients and the y-intercept of the algorithm. So to do that, we just use the coefficient attribute of the regression model. We can print that out. And then we can also print out the intercept attribute. So according to what was printed, our algorithm thinks that there are 3.97 calories per gram of protein. There are 8.817 calories per gram of fat. And there are 3.786 calories per gram of carbs. Of course, this is an estimation and not exactly correct for every food, but it seems to work pretty well. We can see that the y-intercept of our algorithm is 4.405, but in reality, this should not be the case. If we input 0 grams of protein, 0 grams of fat, 0 grams of carbs, we are returned a value that is equal to the intercept, of course. And this should not be the case. So to fix that, we can go back into our code, and when we instantiate this linear regression model, we can say fit intercept equals false. So that'll keep the model from fitting the intercept. It'll maintain an intercept of 0. When we run the code 0, 0, 0, we get 0 calories as expected. Now that we've extracted the coefficients, you could easily do this algorithm in your head. Well, maybe not easily. Let's say we give it 2 grams of protein, 3 grams of fat, 4 grams of carbs, and it returns 50 calories. We could do this ourselves with some simple math. Open up Python 3. So we got 4.125 times 2 grams of protein plus 8.862 times 3 grams of fat plus 3.839 times 4 grams of carbs, and we get 50 calories. So this is one of the most basic machine learning algorithms, but you can use the same format and substitute in other models from other sections of sklearn, and you can do a whole bunch of other stuff if you read up on the documentation. If there's anything that you want me to cover in greater detail in a different video, let me know in the comments. See ya!